Hello and welcome to our webinar on implementing containers and Kubernetes, 5 gotchas you need to know. My name is Ross Beard. I run marketing at Shadowsoft. For those who don't know, Shadowsoft helps organizations modernize their applications and infrastructure. And we help in 3 specific ways. We leverage cloud services, specifically AWS. We implement DevOps practices, and we implement container technologies. Today, I'm really excited for you to join us because we have John Ray, Cloud Solution Architect at Shadowsoft, and he's here to share these 5 gotchas with you. I do want to say a special thank you to our partner AWS for supporting us on this webinar. Shadowsoft is an advanced consulting partner with AWS. We have a number of container engagements under our belt this year, and that is really what spawned this topic and why we wanted to share some of these ideas, because John found a few gotchas along the way, and we wanted to guide you on your journey so you don't make the same mistakes, so to speak. Before I pass it off to John, I do want to ask you to feel free to use the chat pane to the right to ask questions, but we will wait till the end of the webinar to answer them all at once. So about John Ray, he is a cloud solution architect at Shadowsoft, responsible for providing Shadowsoft clients with direction on how they can adopt and operate cloud computing more efficiently and effectively. He spends his time helping clients optimize cloud resources, automate their workflows, and improve IT operational efficiency and agility. On that note, John, the mic is all yours.
All right, thank you, Ross. My name is John Ray. I am a Cloud Solution Architect. I started my life at Shadowsoft as a DevOps consultant, and I've held that role for quite some time. And so now, instead of being the one who implements all of these things, I get to help our clients adopt these practices, and it's a really exciting place for me to be. And so with that being said, we're going to dive in here. And what I want to preface this with is I think everyone understands the value prop of containers. We've all been told about the consistent environments that we're going to get and how we can run our application anywhere, and how we get this incredible speed to market, and our developers are going to love us because we're going to allow them to use this really cool new technology. And so I think everyone's pretty much sold on the concept of containerization. But the real question is, why Kubernetes? And if you'll remember, when containers first burst onto the scene, there were many orchestrators. It wasn't just Kubernetes. As a matter of fact, Kubernetes didn't come on until much later. Originally, we had Docker Swarm, and we even had VMware's implementation, which was a secure VM that you ran a container on. We had Mesosphere and the Marathon product. We had Amazon's ECS, their foray into container orchestration platform. And when Kubernetes came onto the scene, it really took over a lot of the market. And so now, where you had 5 or 6 different competing orchestration platforms, you really only have one. Kubernetes is now supported by Docker. It's supported by Mesos. Amazon now has a really great Kubernetes product that they support. So if we're going to have the promise of being able to run our application anywhere, it also means that we have to choose an orchestrator that is supported everywhere. And Kubernetes is that orchestrator. And so that's really the why around Kubernetes. So as we launch into these gotchas, these are all things that we have seen in engagements with our clients, and they're things that we want you all to be able to watch out for. So the first thing is, there's a lot of extra infrastructure. There's a lot of extra processes you have to consider when moving to containers. It's a technology that enables an incredible amount of velocity, and with that velocity, you have to have certain controls in place. So I want you all to consider things like, where are you getting your images from? Are these images coming from the Docker Hub? Are you building these images internally? Are you automatically building these images? Do you have the supporting infrastructure, such as a CI/CD tool, a container registry, good source control practices, an automation tool, something like Ansible or CloudFormation to deploy these containers in a very rapid manner? If you don't have all of these extra processes and infrastructure in place, then containers really just gives you a really fast way to shoot yourself in the foot. You have to really consider all of the governance that goes around the amount of velocity that you gain when you go to containers. All right, so that's number one. Number two is your application logs. So might be news to some of you, but applications store data. Containers don't. Containers don't actually store anything. The read-write layer that gets added to a container when it's instantiated is lost when it dies. And so you have to really consider in this distributed world, where are my applications writing logs to? Is that location available no matter which node in my cluster the application comes up on? How do I get my logs off of the node? And most importantly, do my logs contain enough context such that I can get information from them without knowing what node this application was living on? I think many of us are used to saying, oh, these logs came from web server A, and I know that web server A has old hard drives in it, and so I know that the storage is a little slow in web server A. And that can help you troubleshoot and debug maybe what your application is doing. When you have a cluster and your application can come up anywhere, and you might not know which part of your microservice architecture is interacting with, say, the storage, suddenly you need context about storage speed in your logs in order to make sense of things that might happen inside of your container. So it's really, really important to consider that. All right, number three, container security is vastly different from your traditional server-based application security. So we're used to thinking about server security as, let me update my patches every quarter when the new patch cycle comes out. And this used to work fine in the past because, again, we used to look at web server A and go, oh, well, web server A is secure because we patched it last quarter. When you're running in containers, you have all kinds of different applications that are running on the same cluster. So not only do you have to consider the underlying cluster and how are we going to secure and update the operating system that your orchestration platform is running on, but now we have to also consider all of these individual applications and their dependencies. So when I pull down an image, am I scanning that image? Do I even know what's in that image? Am I restricting what processes a container can actually run inside? The operating system itself and the orchestration platform, if there is bad code inside of a container, that code can be executed if you don't have the proper security protocols in place. You have to think about things like, how do these applications now pass secrets back and forth? How do I grant access to certain microservices to other microservices, but restrict it from other tenants that may also exist on my cluster? So these are all things that we have to consider. And so because of that, and because of how easy it is to update containers from a build perspective, we really don't have an excuse anymore to just wait every quarter for our container security updates. We have to continually be thinking about security, and we have to enable our developers and enable our operations folks to act upon new security bulletins that come out. We need to be able to rebuild images on the fly, and we need to embed security personnel throughout our organization, because security is a skill set that everyone needs to acquire. It can't just be relegated to a small underfunded team somewhere. So The security paradigm is much different. There's a much larger attack surface, and there's a much greater need for a continuous security model in your organization. All right, so that's got you number 3. Got you number 4 is the architecture paradigm. So as you've heard me say, I might have said microservices. You might be familiar with the term monolith, and these are different ways that we produce applications. And so when we move to containers, there is naturally this move towards microservices as a pattern. Microservices as a pattern is vastly different from monolith architecture, and it comes with its own benefits and weaknesses. So what we have seen with our clients is that there is not a lot of consideration placed upon the need for a microservices architecture. Most often folks just go, well, we're going to containers and therefore we need to use microservices. And those two things don't necessarily align. Using containers as a model for deploying your application software and architecting your application in a microservices fashion are really two different things. And it's important to remember that just because there is this big push in the industry to get away from monoliths, monoliths aren't all bad. Google still runs its entire code search base in a big monolith, and it has 1 billion files and 35 million commits in it. Works just fine for Google. So let's not all jump on the I must change everything about what I'm doing bandwagon in order to be able to leverage some of these patterns. And so that leads us to number 5. When we start talking about distributed patterns and having distributed or microservices style architecture, how we monitor becomes vastly different. We're no longer looking at, hey, is web server A on? Is the IIS process running? Okay, we're good. Now your application is living on a multi-tenant cluster. And things in that cluster may affect your application. Other applications may reserve too much RAM or be pounding the storage array with too much I/O. And if that's the case, it might cause your application to suffer. Traditional monitoring tools can't really keep up with the concepts of a process within a process. So containers are seen as a process running on a node. And while I care about that process and some of the ancillary things like how much processing power that process is using, I need to care about what's going on inside the container. And so when you look inside the container, you have to use different tools than your traditional monitoring tools. The other thing you have to consider is that not only do I have to use a different tool to get inside my container, I have to get those logs. I got to move those logs off to something else. Now I need to consider the context of my entire application. So I, as an application owner, now need to actually care about how do I interact with the database? How am I interacting with storage and networking and the other microservices upon which I depend? All of these things now make up what I call my application, and each of these individual components can impact my application. So I'm now no longer just looking at my single app server and thinking to myself, well, this is the only thing running on this app server. I'm now looking at this multi-tenant distributed architecture and how all of these individual pieces tie together. And so that context is really important when you start looking at monitoring of distributed applications. And there's always one more thing with containers, and even though we have 5 gotchas, there's really a lot of things to consider. And what I want to illustrate here is that there are a lot of choices in the container world right now. Containers are still relatively new technology. Docker itself was only beginning to be widely adopted in 2014. So a lot of these projects have sprung up to attack very specific use cases in the container world. So as you can see, there's a whole lot of choices. And these choices that are shown here are reflective only of the ones that have bought into the Cloud Native Computing Foundation. So there are a myriad of other tools that aren't even listed here. And when you're designing for containers, when you're moving in this direction, it's really important to make very purposeful decisions about which technologies you're going to use for what purpose. So, in summary, we're going to look at certain things here. The first thing is that all of these concepts that I've been talking about, logging, monitoring, storage, these are not new. These are actually old concepts, but they're new implementations. When we went from physical machines to VMs, we said to ourselves, oh no, how do I log all this? How do I manage this environment in this distributed way? And now we're having the same existential crisis in a way around containers, because we know that we need to do these things, but the implementation of logging or monitoring or persistent storage is just substantially different in containers than it is in VMs. The next thing is you have to make sure your processes are worked out. As we talked about before, there are a lot of ancillary things that really make containers work correctly. And if you don't pay attention to your CI/CD and development processes, then what you end up with is a vehicle that makes you go really fast without a lot of control around it. And that can be a recipe for disaster. Your logs need context. And that context is no longer just about your application. Your application logs need to be reporting things about the interactions with other services that are running in your cluster. They also need to be reporting things about RAM and disk space and things like that, because when that container dies, you lose node context for those logs. And so you need to be recording all of that metadata, and that metadata needs to be in your logs and shipped off your logs so that when you look at stuff later, you have that context. Security is so important, and you have to involve security early and often. Continuous security is really the only thing that protects container environments. You have to constantly be looking at, is it time for me to update a Ruby gem or a Python package? It's not just about the operating system patches anymore. And you no longer have an excuse. You don't have to bring your entire app down to patch the base image and to slowly roll out new updates. So this is a continuous model that you have to adopt, and a skill set that has to permeate throughout your entire organization if you're going to really realize the benefits of containers. When you talk about containers, you have to make sure that your application is going to benefit from the change in your architecture paradigm. It's not useful for you to just go to microservices because everyone says we must. I'm sure a lot of us have dealt with your executives or members of your organization saying, we're going to the cloud. It's just, you don't have a choice. And a lot of folks get themselves into trouble when they don't consider, how do I get the most benefit out of a cloud operating model? The same thing is true with containers. If your application is not going to benefit from moving to a microservices paradigm, then maybe we need to rethink what we're doing. AWS has lots of different services that can, help you modernize your application without necessarily changing the architecture paradigm. So it's an important thing for you to consider. And when you do decide that going to a distributed paradigm is something that you want to do, you have to remember that monitoring is different. You're not just monitoring up, down of your application. You're truly holistically monitoring all of the interactions that your application has. You need to be looking at the performance of how you interact with your databases and your storage and your networking, not just whether or not your website is up and if you get a lot of successful, interactions from your clients around, their cart, for instance. You really have to look at your applications holistically because they live on a multi-tenant cluster now as opposed to living on their own independent hardware. And finally, there's a lot of choices out there. There are a lot of things that you can choose to solve specific use cases. And we ask that you let Shadowsoft help you. We can help you look at all of these different choices and help you make the decision that is best for you. So I really appreciate your time. Thanks very much for listening. I'm going to turn it back over to Ross now, and he's got some final words, and then we're going to look forward to taking your questions. So, Ross?
Thanks, John. Okay, so we do have a next step for you if you're ready. It's called a container assessment. And what this involves is people like John Ray at Shadowsoft coming in and working with you to understand your resource consumption, your business, cultural, regulatory requirements. We then co-develop a migration plan that includes best practices for creation of landing zone, use of IAM, a few other items. We identify opportunities for application decoupling to provide immediate agility and ROI for cloud adoption. We know that it's important for you and your stakeholders to demonstrate the value of your business initiatives, and that's where we will partner with you to help tell that story. We'll develop an architectural recommendation based on the 5 pillars of cloud computing framework. And finally, we'll identify and apply available proof of concept funding. So as an advanced AWS consulting partner, we have access to funding to help you take that first step with a POC. So if this is interesting to you, there'll be a little pop-up offer come up right now. Follow that link, and I will make sure you get put in contact with John Ray to discuss your next steps. Okay, on that note, it's Q&A time. I'm going to welcome John Ray back in here. Again, reminder, use the chat pane to the right to ask your questions, and we'll do our best to answer them. Cool.
How does that work? You just stare repeatedly at the screen? Are you going to loop it?